So now I have the last page of the review. So we're taking a look to see about creating another polynomial equation. So write the equation of the exact polynomial that passes through all of these points, okay? Now, when you look at a list like this, those points all have y equal to 0. If y is equal to 0, that's what we call the x-intercept. The x-intercept is what you get when y is equal to 0. So I know that I've got x-intercepts at -1, 1, and 2. So that means that if I were to look at a graph of this guy, so at -1, 1, and 2, those are my x-intercepts. So it looks like the graph is going to be, I'm going to have some function. I don't know what the leading coefficient is yet, but I know I'm going to have x plus 1, x minus 1, x minus 2, okay? Because if I look at these, I know that x plus 1, x minus 1, and x minus 2, these are the factors. I get those straight from looking at the solutions, okay? So that takes care of those first 3 points. Now the other piece of information I have is that the function has to go through the point 3, 24. That means when you put in a 3 for x, you're going to get a y value of 24. So that means that 24 is equal to a whenever I plug in a 3 for x. 3 plus 1, 3 minus 1, 3 minus 2. So 24 is equal to a, and this is 4 times 2 times 1. So that is 8. So 24 equals 8a. So a is equal to 3, okay? So the exact equation is this polynomial is f of x equal 3 times x plus 1, x minus 1, x minus 2, okay? So that is the exact equation here. Let's find the y-intercept before we graph this. To find the y-intercept, that's what you get when x equals 0. So that's going to be 3 times 1 times -1 times -2. So that is going to be 6. So at 0, 6, my graph is going to go through that point. This is a third-degree polynomial and has a positive leading coefficient. So what this guy does is it goes up here, down, and it goes up like that. Okay. So this is the equation for that polynomial. Now let's look at the next one. Write the equation of the exact cubic polynomial with a root of multiplicity 2 at x equals 3, also passing through the points -4, 0, and 0, 4. So -4, 0, y is 0. That is an x-intercept, okay? Okay, 0, 4. The x is 0. That is a y-intercept, okay? Okay, when the x value is 0, that's a y-intercept. When the y value is 0, that is an x-intercept, okay? So I know that my x-intercept -4, 0. There's also a root of multiplicity 2 at x equals 3. So 3, 0 is also an x-intercept, okay? So when I write the equation for this guy, it's f of x equal some leading coefficient, and then I'm going to have x plus 4, and then x minus 3. And I know that at x minus 3, that is a root with multiplicity 2. So this is my cubic polynomial. So I've got everything there. I just need to figure out what a is. Now what they told me was it goes through the point 0, 4. So when you substitute x equals 0, you're going to get a 4. So 4 has to equal what happens when I plug in a 0. Okay, so when I plug a 0 into this equation, 4 is equal to a, and this is 4 times 9. So 4 is equal to 36a. So a is equal to 4 over 36, which is 1 over 9. So this equation is f of x equals 1/9 x plus 4 times x minus 3 squared. So if I were to graph that, 1, 2, 3, 4, here's -4, and then 1, 2, 3. Let me just, for consistency, let's just make that a red because I do not cross there. And I know that the y-intercept is what, 0, 4, right here. It's a cubic with a positive coefficient. So that means I'm going to start down here, and I'm going to do something like this. Go up, come down, and go back up this way, which is the graph of this function. Okay? That should be it for the review. Now keep in mind, this was what we did 4.7 to the 4.10. You'll also need to review that quiz 4.1 to 4.6 to be ready for the unit test.